I'm Roch Gaussoin. I'm the head of the Department of Agronomy and Horticulture at the University of Nebraska-Lincoln. And we're going to have to be able to provide sustenance for a much larger population 50 years from now than we today. And University of Nebraska-Lincoln is poised with great scientists and great facilities and great support from the administration and the citizens to do exactly that. We have a lot of plant breeders in our department whose sole purpose is developing crops that perform better under adverse conditions, possibly for third world countries that maybe don't have the water resources or the fertilizer resources or any of the other things that we have, thank God, in the United States to grow those crops. And so by developing those sort of tolerant traits, whether it be abiotic stresses like heat and drought, or whether it be pest stresses, by doing that here in Nebraska, we can serve two needs. We can serve the producers of Nebraska, but by the same token, we may have a product that can be sent to these third world countries or other places where food is scarce and in demand and population demands it. And so we're really the best of both worlds. We can meet the needs of Nebraska producers while also producing products that can be used worldwide. We're starting to target more stresses like drought or water, and probably water more than anything. The Water for Food Institute is an example of that. That's an umbrella institute over the entire University of Nebraska campus, and not only in the Institute of Ag and Natural Resources, but across campus, involving biologists and plant breeders and management people. So when you talk about putting in a drought tolerant or a water efficient type trait, then you can, the term that's kind of being used quite a bit is more crop per drop. And some may not agree with that concept, but what we're saying is that we can still produce adequate food resources so that we don't have a scarcity of food by simply making plants more efficient at producing whatever the end product is, whether it be grain or fruit or whatever the case may be. We recently got approval for a grant for a system that's going to be put up on Innovation Campus, one of our new facilities. And Innovation Campus will be once again across campus, but they're going to be able to scan plants for certain characteristics, whether it be grain yield or drought hardiness or whatever, very quickly and efficiently. And in the old days, that would have been a plant breeder walking a field, acres and acres and acres, and looking at every plant, seeing which one was responding, and then harvesting them. Now we can do some of that electronically. It doesn't substitute for classical plant breeding. It just facilitates the speed at which we can get a viable, better production type species into the fields. And we've gone to minimum till type systems. That's one of the biggest things I think that has made a radical improvement on what we do, because it conserves moisture and the subsequent crop does a really good job. So that's newer technology, not really new, it's pretty well adapted. But prior to that, we did crop rotations. We'd rotate a legume like soybeans with corn, and then that nitrogen would be replenished in the soil, and the subsequent corn plant could benefit from the planting of the soybeans. So I think all along we've tried to do the right thing, and we've made some mistakes, and hopefully we'll make some more to make us better at what we do. But something like no-till or minimum tills operations have been really huge. They're also finding out now that the grazing of corn stover by beef is they're actually putting on more weight gain than they ever thought. They kind of considered that a filler, and when you consider that, then maybe there'll be another way to sustain or continue to produce, not only at the levels we're at now, but at the projections to increase production by 100%.